Hello everyone, welcome back to my channel. I am Vandana, student of Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Information Science and Engineering, first semester EHL section. Today in this video we are going to learn about the subject Applied Physics, particularly about the topic animation. Contents for the selected topic are animation, the taxonomy of physics-based animation methods, frames per second, size and scale, proportion and scale, weight and strength. Now let's come to animation. Animation is a method of photographing successive drawings, models or even puppets to create an illusion of movement in a sequence because our eyes can only retain an image for approx 1/10th of a second. When multiple images appears in a fast succession, the brain blends them into a single moving image. Animation is the process of displaying still images in a rapid sequence to create the illusion of movement. The taxonomy of physics-based animation methods. At the highest level, the field of physics-based animation and stimulation can roughly be subdivided into two large groups. First one, kinematics is the study of motion without consideration of mass or forces. Second one, dynamics is the study of motion taking mass and forces into consideration. Kinematics and dynamics comes in two flavors of subgroups. First one, inverse is the study of motion, knowing the starting and ending points. Second one, forward is the study of motion, slowly given the starting point. Now let's come to the frames. A frame is a single image in a sequence of pictures. A frame contains the image to be displayed at unique time in the animation. In general, 1 second of a video is compressed of 24 or 30 frames per second, also known as FPS. The frame is a combination of the image and the time of the image. When exposed to the view, an extract of frame in a row makes the animation. Frames per second. Animation shot on film and projected is played at 24 frames per second. Animation for television in Europe, Africa, the Middle East and Australia is played at 25 frames per second. An animated film with 25 frames per second is played on television at 24 frames per second would result in black bar rolling up the screen. The digital converts are used to be transfer one speed of film to another speed of video. The most important thing to find out when animating something is what speed the animation will be played back at. Size and scale. The size and scale of characters often play a central role in the story's plot. What would Superman be without his height and bulging biceps? Some characters like the Incredible Hulk are even named after their body types. We often equate larger characters with weight and strength and the smaller character with ability and speed. There is a reason for this. In real life, large people and animals do have a larger capacity for strength, while smaller creatures can move and maneuver faster than their large counterparts. When designing characters, you can run into different situations having to do with size and scale, such as first one, human or animal based characters that are much larger than we see in our everyday experience, superheroes, Greek gods, monsters. Second one, human or animal based characters that are much smaller than we are accustomed to, such as fairies and elves. Third one, characters that need to be noticeable, larger, smaller, older, heavier, lighter, or more energetic than other characters. Fourth one, characters that are child versions of old characters. An example would be an animation featuring a mother cat and her kittens. If the kittens are created and animated with same proportions and timing as the mother cat, they won't look like kittens, they all just look like same adult cats. Proportion and scale. Creating a larger or smaller character is not just a matter of scaling everything about the character uniformly. To understand this, let's look at simple cube. When you scale a cube, its volume changes much more dramatically than its surface area. Let us say each edge of the cube is 1 unit length. The area of one side of the cube is 1 square unit and the volume of the cube is 1 cuboid unit. If you double the size of cube Along each dimension, its height increased by 2 times and the surface area increased by 4 times and its volume increased by 8 times. While the area increases by squares as you scale the object, the volume changes by cubes. Weight and strength. Body weight is proportional to volume. The abilities of your muscles and bones, however, increases by area because their abilities depends more on cross-sectional area than volume. To increase a muscle or bone strength, you need to increase its cross-sectional area. To double a muscle strength, for example, you would multiply its width by root 2. To triple the strength, multiply its width by root 3. Since the strength increases by squares and weight increases by cubes, the proportion of character's weight that it can lift does not scale proportionally to its size. Let us look at an example of somewhat average human man. At 6 feet tall, he weighs 180 pounds and he can lift 90 pounds. In other words, he can lift half of his body weight. If you scale up the body size by a factor of 2, the weight increases by a factor of 8. Such a character could then lift more weight, but since he weighs more than 8 times more than he did before, he cannot lift his arms and legs as easily as normal man. Such a gains strength but loses agility. Thank you for watching this video.